Shield Lab is an AI-powered security command center that moves beyond a normal vulnerability scanner. The project core idea is to find security, use reason about real-world risks, connect attack paths, generate fixes, and also helps to create the remediation pull request. In the homepage, you can see different options. Now let's talk about Threat Radar. Here, it helps you track the recent CVE from public vulnerability intelligence filter by severity and time window, and also shows the AI-assisted developer impact summaries. It helps you face the recently discovered CVE, and if you click on the visit advisory button, then you will be redirected into a link where you will be able to read in more brief, in more detail about all of this CVE in very detail. And here you can see the code scan, and in this code scan, you need to give the URL of a GitHub repository that you have. That you need to give the URL of your code, and if you paste the code and launch the scan, then this scanner helps to clones the repository, parse the code base, runs vulnerability detection automatically, and also filters likely false positive, and also helps to generate the fix suggestion, calculate CVSS severity, and also saves the finding. Many vulnerabilities that can be covered by Bandit and my custom head detectors like hard-coded secrets, SQL injection, XSS scripting, and many others are found. Here the report or the result has been generated, but Shield Lab just doesn't stop over here. It doesn't only say that this is vulnerability, but also helps you to generate the fix for this vulnerability. And if you don't want to implement those fixes manually, then it can automatically implement all of these fixes automatically in your GitHub using the auto PR feature. Here you need to give the GitHub SSH token, and it will automatically implement all these suggested fixes to improve or to fix this vulnerability in directly at your GitHub code base. And this is our second feature, web scan. Here in the web scan, you need to give the URL of your website, and since I don't have an URL that is hosted, I will be using the local host, and this is my local host I will be giving. And in this passive scan, we have two scan, passive scan and active scan. In passive scan, you'll be using Nmap and nuclei to find the exposed vulnerability, security header checks, and a lot of other things like nuclei templates in your URL website, in your live website. And in the active scan, you'll be giving the URL parameter that you are quite confident there might be a SQL injection. So I have this URL parameter, and I'll be adding it over here, and right now it is scanning for the SQL injection, and we are doing it using the SQL map. And this is the result. Here you can see a lot of vulnerabilities were detected, and as you can see over here, SQL injection confirmed. So the active scan we did here, it found the SQL injection for sure. So this is all other vulnerabilities that were discovered by the web scanning. The most powerful is combined scan. Here you need to give the GitHub repo URL and the website URL. They both must be same in a sense that the same GitHub repo code must be hosted as a website, and it helps to merge the code findings and the web findings and calculate severity across all of them, and then run cross-domain attack chain analysis to show how multiple weaknesses could combine into a real attacker path. Of course, the active scan is also involved, SQL injection is also involved, so it helps you to understand how a real attacker might attack by using the small vulnerability or every vulnerability that were found in your code base, and also the vulnerabilities that are discovered using the web scan using Nmap and nuclei. So it is one of the most powerful that we present, and of course the code fix are also generated using AI, and of course if you want to fix those vulnerabilities in your code base, you can of course use the auto PR feature also. Without Codex and GPT 5.6, this entire architecture is unimaginable for me, because they help to accelerate the engineering workflow as an AI-paired programming partner. It helps turn the architecture into working code faster by assisting with fast API routes, scanner orchestration, React White UI components, scanner integration, database persistence, bug fixing, test, documentation, and repeated refactoring. Codex was especially useful for connecting many moving parts together: backend API, background scan pipelines, code scanners, web scanners, AI reasoning agent, front-end dashboard, threat radar, and auto PR validation into one runnable prototype. While GPT 5.6 and Codex contributed by helping translate my entire product decision into implementation details, suggesting safer structure, speeding up debugging, generating validation checks, improving documentation, and polishing the final demo workflow.